Hey everybody, Mr. Mack here. Today we are going to graph some lines. This is review from algebra, but we are going to need to use this in some units coming up. So let's review how we can graph lines. First thing I want to talk about is the different ways that the different methods that we know how to graph lines with. And one is make a table, another is find the intercepts, and another is find slope and y-intercept. So let's start off with make a table. So we can always, if we're given an equation here, we can always just make a table of values. So I've got x and y values, and I can just plug in something for one and solve for the other. So how about we try maybe how about just 0, 1, and 2 for x. We'll just try that. So we're going to plug in 0 for x plus y equals -4. So y equals -4. Okay, so we have 0, -4. Let's try 1. 1 plus y equals -4. Y, so we subtract 1 to both sides. Y equals -5. Let's try, so we've got a -5 for that value. And let's try 2 plus y equals -4. Subtract 2 to both sides. Y equals -6. And maybe I can try a negative for x. How about we try a -2? So I've got -2 plus y equals -4. Add 2 to both sides. Y equals -2. Okay, so I can now plot these points. We've got 0, -4. We've got 1, -5. We've got 2, -6. I've gone off the chart here. And -2, -2 right there. And I'm going to draw a line through those points. And there we go. Graph the line. Okay, so it's good to have, I would say, the minimum you need is 2 points, but it's good to have at least 3 because it kind of checks your work. Okay, so let's do it by finding the intercepts. So in order to find the y-intercept, that means that our x value has to be 0. And if we want to find the x-intercept, it means the y value has to be 0. So essentially, it's like making another table, but we're going to put 0 for x and find what our y value is, and then we're going to put 0 in for y and find what our x value is, and then we're going to graph it. Okay, so we have the same equation here. We have x plus y equals -4. And so we're going to put in 0 for x, and we're going to solve for y. Well, this is pretty easy, because if we get 0 on this side, there's nothing else to do. So we have -4, 0, -4. So that's one of our points. 0 on the x, -4 on the y, right there. Now let's put in 0 for y. Well, this means that x equals -4. So -4 on the x right there. And now we have 2 points. We have our y-intercepts. We can graph the line. notice it's the same exact graph as we did for this first one. It better be. It's the same equation. All right, find the slope and the y-intercept. Okay, so we have x plus y equals 4, x plus y equals negative 4. And our slope-intercept equation is y equals mx plus b, where m is the slope, right? That's the rise over run, and b is the y-intercept. Okay, so we have to solve for y, and we write it in this order: our x term and then our constant, and then we can just read what we get. So I need to subtract x to both sides. I get y equals negative x minus 4. And so this means that my slope is negative 1, because that is the coefficient in front of x. Or I can say, another way to write this is negative 1 over 1. And b is negative 4. It's this value right here. So first we plot the y-intercept. And the y-intercept is negative 4. And then we go down 1 over 1. Or we can go up 1 to the left 1. And we draw our line. And almost kind of missed that a little bit. All right. There it is. And you can see that these three methods all give us the same line. Okay, very good. So those are three different methods. You can try number 2 on your own. Let's take a look at number 3. I'm just going to do a couple of these, and you guys can do the rest. Find the x and y-intercept, write in slope-intercept form graph. Okay, so first thing we're going to do is find the x and y-intercepts. So we're going to substitute 0 in for x and find y, and then we're going to substitute 0 in for y and find x. Okay, so let's do 2 times 0 plus y equals 1. 2 times 0 is 0, so y equals 1. So 0, 1 is our first intercept. This is our y-intercept. That's the y-intercept. And get ocean here. Now we're going to write the equation 2x plus, now I'm substituting 0 in for y here. And so I get 2x equals 1, x equals 1 half. So 1 half, 0 is my y-intercept, right there, 1 half 0. And then so there are my y-intercepts. I could graph this. I could make my graph here of this line. It's a little bit tricky because, you know, that half mark and these 2 points are so close together, but we could still do it. There it is. But we're also going to write in slope-intercept form, and this could maybe give us a better idea or just more confidence in our graph here. So I'm just going to rewrite 2x plus y equals 1. And now we're putting this, we need to write this in y equals mx plus b form. Okay, so I have to solve this for y. So I'm going to subtract 2x to both sides. And we get y equals negative 2x plus 1. So that means that the y-intercept is 1. And the slope is negative 2 over 1. So I would start at 1, and I'll go down 2 over 1, down 2 over 1. It looks like I'm right on the line, so that worked. Okay, so there is in slope-intercept form. Here I have my x and y intercept, and then there's the graph. Okay, I hope that makes sense. So you got a couple of these to try. Let's take a look at 7 and 8. Okay, so for 7, we've got y equals -4. Okay, so if I want to find my intercepts here, and I say, okay, well, I'm going to plug in 0 for x and see what I get for y. Okay, so let's plug in 0 for x. Well, y equals -4. There is no x to plug anything in, so -4 is going to be our y-intercept. And then I say, okay, well, let's plug in 0 for y, and let's plug in 0 for y and see what we get for x. And then I do that, I get 0 equals -4, which is not possible. So that means that we don't have an x-intercept. It doesn't exist. Doesn't exist. So what is going on with this? Well, no matter what, and if I think about it in terms of making a table, no matter what value of x that I write, -2, -1, 0, 1, and 2, I'm always going to be at -4. It doesn't matter what my x value is. Y equals -4, and that's it. So at -2, at -4, I'd be there. At -1, -4, I'd be there. At 0, -4, and this, and this. And what's happening here? This is a horizontal line through y equals -4, right there. So this is already written in slope-intercept form. It's just that 0 is the slope right there. That would be our m value. So that means we are rising nothing. So it's just going to be a horizontal line. Okay. This is kind of the other type of situation. X equals 5. Well, no matter what value for y we put in, x is always going to be 5. So here, if y is 3, it doesn't matter. X is going to be 5. If y is 4, x is always going to be 5. So when we get this x equals some sort of constant, a number like this, that just means we're going to have vertical line. So these end up being vertical lines, and the other ones are at y equals a constant are horizontal lines. Okay, that's a unique case. So these are going to be vertical, and these are horizontal. Okay, if you recognize it, it's actually a whole lot less work. Okay, so there's a couple more there to try, and let's take a look at the next section here. We're going to do graph and write an equation in slope-intercept form. Okay, so I'm giving you here the intercepts. So the x-intercept is -2. That means we cross the, let's get another color here. We cross the x-axis at -2. Boom, right there. The y-intercept is -2. We cross the y-axis at -2, right there. Grab our straight edge. And so we're going down to, over to, so we are going to plot that. Right there is our line. Okay, going through the intercepts, and it says write an equation in slope-intercept form. So that's y equals mx plus b. And so what's happening? Our b is -2, and we are going down 2 units. Down 2 is a negative, and over 2 units, that's a positive. So my slope is -2 over 2 x plus a -2, or just -2. This is my equation, but -2 over 2 simplifies. I can write this as -1x minus 2, or even if I just want to say y equals -x minus 2, this is my slope-intercept equation. Okay? There's that one. You could try number 12, just modeled after 11 if you're not sure. All right, we're getting there. Write the standard form of the equation of each line given the slope and the y-intercept. Okay, so ax plus by equals c. This is the standard form for a linear equation or equation of a line, which is different than the quadratic where we set it all equal to 0. Okay, so a little bit different. We are given the slope and the y-intercept. So we're starting in y equals mx plus b form, but we want to turn this into ax plus by equals c form, or standard form. So my slope is -4. Put that in there for m. My intercept is 3. I put that there. And now I need to move this part over to the left by adding it to both sides. And I get 4x plus y equals 3. And yeah, there it is. Okay, so write the standard form of each equation of a line, and there it is. Yeah, done. That's all we do for that one. How about I do one with a fraction in it? How about I do 16 here? Take a look at 16. So we have y equals mx plus b, because we're given the slope and the y-intercept, so that works with this form. 1/5 x minus 4. Okay. So we can subtract 1/5 x to both sides. And we get -1/5 x plus y equals -4. We really don't like to have the leading coefficient here, the letter a here in front of x. We don't really like it being a fraction, or really don't like it being negative. We really want this number to be positive. So what can we multiply through to get rid of this negative fraction? Well, we can multiply through everything by -5, and it should do the trick. So -5 times -1/5 is just x. -5 times y is -5y. -5 times -4 is 20. And this is the best standard form equation for a line that we could write, given the slope and the y-intercept. Okay? Very good. In this section, we're going to use the point-slope form of the equation, which is right here, where we have a point x1 and y1 and a slope of m. And we're going to use these two things in order to write the slope-intercept form of the equation, which is y equals mx plus b. Okay, so here we have a point and a slope, so the -1 is an x1 value, and the 1 is a y1 value, and there's our slope, so we're just going to substitute it into our equation. We've got y minus y1, which is 1, equals 1 times x. Let's zoom in on this. X minus -1. Substituting the values, especially when it's negative in parentheses, is a good idea. That's going to make sure that we don't miss a negative number. So this ends up turning into a +1. And distribute the 1 here, I get y minus 1 equals x plus 1. And then I need to add 1 to both sides, and I get y equals x plus 2. And we see the slope of 1 right here in front of the x value, which is, we already knew that, and we have a y-intercept here of 2. Alright, there's that one. Okay, next one. I want to do the same thing, so I'm going to take my equation. I'll rewrite it this time since it's covered up. Y minus y1 equals m times x minus x1. In this case, x1 is 2, y1 is 5 and my slope is 2, as I'm given right here, right? That's x1, y1. Just going to substitute everything in. Y minus 5 equals 2 times x minus 2. I'm going to distribute the 2, and I get 2x minus 4. I need to add 5 to both sides. I get y equals 2x plus 9. No, I get plus 1. Negative 4 plus 5 is 1. My slope is 2 and my y-intercept is 1. Okay, so that's all we need to do with this section. We got 2 more here. I'll leave it up for you guys to do. In this last one here, we got 2 points. And we're looking for the slope-intercept form of the equation, which is y equals mx plus b. So we need to find m and we need to find b. So we have an x1 and a y1. That's our first coordinate. And we have an x2 and a y2. And the way we find slope is by finding the rise over the run. And the rise is the change in the y values. So the difference of the y values over, let's do that, y2 minus y1 over the difference of the x values. So I've got x2, trying to color code this, minus x1. And this gives me the slope. So let's put everything, so I'm going to write m equals, okay, let's put everything in. So negative 5 minus 2 over 0 minus 5. Okay, negative 5 minus 2 is negative 7 over a negative 5. So a negative over a negative is a positive. 7/5. Okay. Now we can use the point slope form, which is y minus y1 equals m times x minus x1. And we have our slope here that we can put in. And we could put either one of these 2 points in for x1 and y1. Since I already have labeled this one x1, y1 here, I'm just going to go ahead and put this in. So we're going to get y minus 2, okay, I'm looking at this y1 value here, equals, let's put in our slope, 7/5 times x minus 5. Okay. Now, let's distribute the 7/5 in, and that's going to give me 7/5 x minus, okay, what's 7/5 of negative 5? Well, that's just going to be negative 35 divided by 5, which is negative 7. Add 2 to both sides. Nearly there. Y equals 7/5 x minus 5. Okay, and we can see this is our y-intercept here, negative 5, and our slope is 7/5. So we can graph that if we needed to. Let's do one more. Let's see. How about let's take this right here and copy it over. So we're going to use that equation. And we'll take this one too, maybe. And that doesn't want to copy because I've got to do merge visible. And then I'll copy and I'll just stick that. Stick that just right over here. Okay. It's kind of small though, isn't it? Very good. Okay, what am I doing? Let's label this right here. We got X. Should I color code this one too? I've got, so this is, I'm already in blue, so I'm going to go ahead and put that. That's X2, Y2, and then red is X1, Y1, and we're just going to substitute everything in. So we got negative, what am I doing here? Y2 is negative 1 minus 5 over negative 1 minus 5. Okay. This is easy. Negative 6 over negative 6. My slope is 1. Okay, that's nice. So 1 is going to go in for my slope. And now I have to choose one of my points. I'll just stick with the 5, 5 again. So y minus 5 equals 1 times x minus 5. And distribute. 1 times this, that's just x minus 5. And then we're going to add 5 to both sides. X is all that's left on the right, so y equals x. So there's nothing written here after the x. So what does that mean? It means that our y-intercept is 0, which means we're going to get our slope of 1 over 1. It's just going to be this diagonal line like this that goes right through the origin. Okay, very good. I've done a couple of examples here for this last part. I hope that helps.